The second method for evaluating project alternatives is internal rate of return, IRR. We have two learning objectives today. Explain the internal rate of return, IRR method, in project financial evaluation, and compare project alternative using this method, IRR. First, what is the internal rate of return? Basically, the interest paid or received on the unrecovered balance. The interest paid or received on the unrecovered balance. How to determine IRR? The method we call it IRR. How to determine? Basically, we set the equation net present value and the unknown is the interest I equal to 0. Those to show the I in that equation. And from that I, we mean the IRR, E, the I star, which max the above equation numerically correct. The NPVI, the above equation equal to 0, numerically correct. Basically, that is the solution of that equation. And with that, if for one project, if IRR greater than or equal to 0, greater than or equal to MA, minimum attractive rate of return, not 0, MA, then we call that that alternative is financially viable. If the IRR greater than minimum attractive rate of return. And what are the other terms we use for this? So for IRR, other terms that using this is return on investment, or return on investment, that is ROI, or return, rate of return, rate of return, ROR, or profitability index. Profitability index. So those are the terms it can use for IRR. For this class, we use IRR. So let's apply one problem 1 here to find out the IRR. If 5,000 is invested now in the common stock, let's draw the cash flow diagram. Yes, 5,000 invested now. 5,000 invested, so it's going down 5,000. And it's expected to yield 100 per year for 10 years and 7,000 at the end of year 10. So that investment lasts for 10 years. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You 100 per years for 10 years. 100 per years. Same amount every year. And that is 100 per year. And at the end, we get 7,000 at year 10, 7K. And the question asked is, what is IRR, internal rate of return? And that you can see here how to determine IRR. We set NPV equal to 0, and the I star, which made that equation equal to 0, numerically correct. It means that the IRR. So with that one, we get the equation NPV, and in this case we have I. So consider I an unknowns in that case. Then we write that equation. Print all the money NPV. We already learned in the previous lesson, the present value. Print all the money in the cash flow 2 times 0. So from that we have negative 5K plus, we can put that with 5,000. It was 100 there. 5,000 plus A, in this case, A is equal to 100, and that is the factor, one same amount over 10 years. So print it to present value, P over A. We don't know I. For how many years? 10 years. And then at the end, we have 7,000 plus 7,000. One single amount at year 10, bring it 2 times 0. So P over F I 10 years. And that make that equation equal to 0. Equal to 0. So how to solve this problem? How to solve this problem? We have two methods. The first one is trial and errors, which you may not like it, but I go over one, and then use your calculator. So let me use the first method, is the trial and errors. And error. So trial and errors, just try certain I to see whether it reach that equation. So the first try, let's see. Let me try this. Try I equal to 6% and plug into that equation. What do you have? So 6%, go to the reference and look for the table 6%. 6% there. And we have two components, P over A, 6%, and P over A, I, 10, that factor. And then we have P over F, I, 10, 0.5584. So from that one, we can have that NPV at 6%, plug in, equal to 5,000 plus 100 times the factor we just showed you, that is 7.3601 plus 7,000. The factor is, for P over F, I percent 10 equal to 0.5584. From that one, we have NPV 4%, 6% equal to negative 355.19. And then you can see this one is less than 0. We want the I equal to NPV equals 0, that is I. But at 6%, NPV is negative number, 355. So the next try, what should be the next try we should have? Whether you go down to 6%, to 2%, to 4%, or we go up to 8%. As you can see, for this one, the more we go up, it's more negative. Because print the money, the interest increasing, the value amount, it will be go back to the time 0, it will be less. So in this case, if you increase the I%, then we get more negative number. So with that, if it's negative number when you first try, 6%, then you need to go the next try, it should be lower. So that here, I try I equal to 4%. Lower, so hopefully we get a positive. So from that one, we have NPV equal to 4%. Similarly, 5,000 plus 100 time factor, and of course 7,000 time a factor. And go back to here with 4%, and the two factor that we have it in there equal to P over A 10 years 8.1109. P over F for 10 years 4% 0.6756. So from that we have that here is 8 8.1109, and this one is 0.6756. From there we have NPV at 4% equal to a positive number 540 29, and this is greater than 0. We want it equal to 0 to make it equal. So with that we can interpolate. So first try, second try, one positive, one negative. So as you can see, what does that mean? Here, if we draw in the I and percent, and then the NPV, and what do we have here? With NPV equal to 4%, so it means, and 6%, so we have 4% equal to 540. So with 4% and 6%, with 4%, and you can see that if 540 positive, so somewhere there 540. And then with 6% it's 355, so somewhere there. Then we have these two number, the 2 point, and we assume it linear. Of course it's not linear, it's a curve, we assume a linear. Then the line between those two here, and the I star is somewhere here. That is the I star, and that I star equal to IRR. Make sense? So with that we can do the interpolation. To find out IRR and equal to I star, and I star in this case equal to, as you can see, 4% plus make NPV equal 0, so it will be 0 minus NPV 4%, so 540.29 over NPV 6%, negative 355.19 minus NPV 4%, minus 540.29. And then we have the ratio of the time, 6% minus 4%. From that one, we have IRR equal to 5.21%. And that is the rate of return of this investment. And that the first one is the trial and errors. If we use by calculator, or by calculator, okay, and with that I make a note here. You should be familiar with this method, so practice with your calculator. Should be familiar so that you can do with this problem. So how can we do that with here? From the NPVI equal to that, right? So with that one, let's rewrite that equation. NPVI equal to 5,000 plus 100 P over A, I percent, 10 plus negative 5,000 plus 7,000 P over F, I percent, 10. Then you will, and it equal to 0. Then you use the equation in the reference, the first page of your reference, with here P over A, I percent, and that equation there, and then P over F, I percent, and in this case 10 years for this problem, that you have it in there. So those two equations you can write down in here so that we can have it. NPV I equal to negative 5,000 plus 100. And then the first equation, as you can see here, 1 plus I power n minus 1 over I, 1 plus I time 1 plus I power n. And then P over F, I percent, n equals 1 plus I power negative n. So from that one here, we have that is 1 plus I power n, in this case n is 10 years, 10 minus 1 over I, 1 plus I power 10 plus 7,000. This is 1 plus I power 10, negative 10 power, then it over 1 plus I power 10, and that equal to 0. So this is one equation, one unknown I star. So with that you can solve for I, and with that one you can see an I, and in that one it IRR, what the calculator you have. So make sure you plug in your calculator with that equation, practice, and show that it's about the same. That number here is a little bit different, but 5.21%, and that should be per year, our equation per year. So that per year makes sense. So with the generation here, our generation is calculator, use calculator. So practice that and make sure you get the answer.